So this time I will show you how to find internal reaction in a beam. So first of all you should know what is internal reaction. So say there is a beam and it is simply supported, that means one hinge support, one roller support, and say it has a load here and some load here, and the dimension of the beam, say this is a 5 feet, 4 feet, say this is all 6 feet, and this value is say 10 kip, this value is say 2 kip per feet. Say this is a very simple beam, simply supported, that means one hinge support, one roller support. It has only two loads. One load is 10 kip concentrated here, and other load is uniformly distributed load. Uniformly distributed load of 2 kip per feet here. Now the question is about what is the internal reaction. So internal reaction say here. That means at this point say it is C, say this is A, and it is B. So the question is internal reaction at C. This is our question. What is the internal reaction at C? Now internal reaction means three forces that may occur inside the beam. That is shear force, and next is bending moment, and third is normal force. So say I have a beam, this is my beam, I have different kinds of load. So inside any point, so these three forces may occur. One is shear force, one is bending moment, one is normal force. Now let us see how to find this. So before finding, what to do? As it is internal, we need to cut here. And then analyze it. So if you cut here, and we can consider left part or right part. Whatever part is easier to you. Here I can see here, if I cut here, it has one load, one support. If I take this part, one load, one support. So almost similar. I do not know which one is easier, but both side is okay with me. And what I will do, I will consider the left part. Why? No reason. I can consider right part also, but any one is good. Okay, if I consider left part, before considering left part, I need to find any external support reaction. So this is a support. I need to find my reaction here. If I have to consider right part, I must determine the external support reaction in the right part. So as I will consider left part, I will find my reaction here. Let us find reaction. So how to find it? We draw free body diagram. That means we assume some unknown here. Say AY, this is AX, this part is say BY. Now question is why two unknown here, why one unknown here? Because this is a roller support. It cannot apply or restrict this way. So there is no unknown here, only unknown here. This is a pin support or hinge support. It has two unknown. One is this way, one is this way. But there is no moment here. Okay, so how to find AX? I can see that there is no load along horizontal reaction. So very easy for me to find AX. Summation of force along X direction is 0. Then what is my unknown force? Say I am assuming this way positive. So my one unknown is AX, this way no other unknown, so AX is 0. So I found one external reaction. Then to find AY, if I apply summation of Fy to unknown, So better to apply, take moment here. So if I take moment at B, moment at B is 0. So I'm taking moment here at B is 0. Then what can I do? And then I'm considering clockwise moment positive. So if I take moment here, and that way is my positive. So my first load is AY times my distance. What is my distance? From here to here. So 6, 4, 10, 15 feet. 15 feet. That is my moment about B for AY. Now it is going that way. That means clockwise. Clockwise means positive. Done. Next force is this one, 10 kg. Now about this point, this load is going counterclockwise. That means it is negative. So 10 kg. What is the distance here to here? Is 10. 6 for 10 feet. What is my third force? Third force is this uniformly distributed, 2 kg per feet. So if it is uniformly distributed, you learned from your previous class that we can consider this concentrated. 2 kg per feet times how many feet? 6 feet. 6 feet. Total is 12 kg. If I am not wrong, no, I am not wrong. So 2 kg per feet, total 6 feet, that means total is 12. Where it is acting? At the middle. Middle means 3 feet, because 6 feet, middle is 3. Why it is 3? We know that for a rectangular area, say this is a rectangular area, its centroid is at the middle, and this is both it. Okay, so and this will give me counterclockwise moment. So 12 kg times 3 feet, and no other force, so 0. If I solve it, and I got 9. So I got 9 kg. So I did this mathematics very quickly, so I might make some mistake, but before going on, check one more time. So it is 10 times 10, 100, 3 times 3 times 12, 36, 136, 9. So 9 points something, so I consider 9. So I know this reaction, I know this reaction. So now I can cut here and consider this part. Okay, so I will delete it. Now if I cut here, what I will see? I will see this. And you know that so my shear force will be this way, moment will be this way, normal force will be this way. We learned it from our previous lecture that if you cut somewhere and we assume V downward, moment counterclockwise, axial force from the point. This is the positive sign convention. Okay, so and this is now known, it is 9 kg and AX is 0. AX is 0, that means we can easily delete it. Now can we, oh, I forgot the distance. Yes, in the problem I did not tell you the distance, but this should be known. This should be known. Say this is 2 feet. Yes, in the problem I forgot to tell you that distance of C. Say it is 10 feet, but it should be given to you earlier. Okay, now can we find V, N or M? Yes. If we apply, say, summation of Fx, summation of force along x direction is 0. What are my forces? N, no other force. So N is 0. N is 0 because there is no horizontal force. If I consider summation of Fy, then 9 keeps, and say we are assuming upward positive. So 9 keep up, this V is downward, 10 is downward, no other force along this way, so it is 0. Then it come 10 minus 9, so B is 1 keep. So we found our P also. It is nothing, as long as we know the external support reaction, we can cut anywhere, apply our equilibrium equation. Then still my moment is unknown. What can we do? We can apply summation of moment here, we can apply summation of moment here. Whatever point is easier to you. Let me apply summation of moment here. If I apply summation of moment here, so summation of moment at A is 0, say clockwise is positive. So I'm applying here, first force 10, distance 5 feet, next force V. What is the value of V? Now I know it, 1. So 1 keep, distance 5 plus 2, 7. So I consider this one, I consider V. N will not be considered because N is going through, say, this point A. So it has no moment. Next moment is this moment. And it is, I assume, clockwise positive. This moment is counterclockwise. So it is negative. Minus M equals 0. Now if I solve it here, it is coming, M is 57 cubic feet. So I found that at point C, my normal force is 0, shear force is on, moment is 57 cubic feet. So this is the way to find internal reaction. Now if it is other point, same procedure, just think which side you will consider, left side or right side, then find the external reaction of that side. Once you found the external reaction, cut that point, and then show your shear force, normal force, moment, and then apply equilibrium equation. Whatever method you follow, whatever side you take, answer must be same. Okay, we will see one more example in our next lecture. Thank you.